Hello student, welcome our channel The Physics Point. Today I am going to discuss the new concept in the part of the physics, that is the mechanical properties of the solids. Let's take the heading, that is the mechanical properties of solids. We know that they have three different states of matter: solid, liquid and gases. But we are studying the mechanical properties of solids. The mechanical properties does not able to study in the liquid state or in the gaseous state. The mechanical properties only study about the solids. But why? Because the solids have the definite size and shape. It have the definite size and the shape. Solid has a definite size and shape itself. The liquid does not have a definite shape. When we are taking a liquid and put in another pots, they have cubic in shape. They take a cubic shape or cubic size. But they are again put in the spherical shape pots. They take a shape of that particular pots. But the solids having the definite size and shape, the spherical pots, the pot is made up of the solids. The solids have definite size and shape. We in the today's lectures we have discussed the two different properties of the solids. One is elastic property. This property is known as elasticity. Another property is the plastic property. This property known as plasticity. Before the discussions of these types of the property, we take the heading, that is deformations. The process is, this is one of the process, the deformation. The deformation, it is the process which can be changes the size and size of the solids, shape of the solids, or the both of the solids when we applying certain external deforming force. It is the process. It is the process. It is the process in which it is the process in which the solids or object changes their size or their shape, or sometimes both size and shape, both, when applying external unbalanced force. When applying external unbalanced, or this is not be unbalanced, external deforming force. External deforming force. And we take the two properties, plasticity and elasticity. Before the discussions of the deformations, I will tell you the plasticity and elasticity. When we are taking one of the examples of the elasticity, the rubber bands, when we apply certain external force, external deforming force for the changes, when we are stretched the object or stretched the rubber bands, it will be changes their size, increase the length of the rubber bands. But when we are release our hand or remove this deforming force, it's regain its original positions or original shape and size. What will be tell, I will repeat again. When we applying certain external deforming force to stretch the length of the rubber band and remove that deforming force or remove that stretching force, then these rubber bands comes again its original size or original length. It is the force is taking the part of it comes its original position. These force is known as restoring force. It's restore again this original shape, original size or original length of the rubber bands. then this force is known as restoring force. The restoring force is opposed to the deforming force. Another one comes in, that is the restoring force. Restoring force. The force which is trying to regain its original shape. The force try to regains the original shape or size of the object after the removal of deforming force. It is the opposed to deforming force. Then this force is created inside. This force is created inside the object. We know that the Newton's third law of motion, every action has equal and opposite reaction force. If we apply the deforming force as the action force, then a part of the reaction force is known as restoring force. These two forces are opposed to each other. It means the same magnitude, but direction will be opposite or different. Then we are directly going to discussions of the properties. The first one property is elasticity. The property in which the object will becomes its original shape, original size, or both after the removal of its external deforming force. The properties of solid, the property of the solid, the property of solid in which the object or the solid objects comes or regains its original size, shape, or both. The solid object regains its original shape, its original shape, or its original size, or both, when after the removal of external deforming force. After the removal of deforming force. After the removal of deforming force. I will tell again. Elasticity is the property of the solids, which property of the solids in which the solid object, regains, this is the underlying sentence, regain its original shape, original size, or both size or shape after, this again underline the sentence, after the removal of deforming force. After the removal of deforming force in the elastic material, the materials which are shows the property of elasticity, this solid material is known as elastic material. In elastic material, the deforming force and the restoring force in an equal magnitude. In the elastic material, the restoring force as well as the deforming force in the equal magnitude. Then the example is a rubber band. Rubber band is the popular and best examples of the elasticity. Then again one, the plasticity. Plasticity, it is one another property of the solids. This is the also property of the solids, but in which the solid object does not regains its original shape, original size, or both after the removal of external force. I will return in a short. It does not regain, completely regain, or does not regain its original size, shape, or both after the removal of external unbalanced force, in which the restoring force is a zero, negligible, or less than the deforming force. The restoring force, that is, I will tell you F of R. The restoring force is less than the deforming force in the plastic material, because the deforming force is large. When the time of dominance of the restoring force, they will be neglected or they can't be dominant, then these object is permanently changes their size and shape, or the permanent change in size or shape after we applying the deforming force. Then this is known as the plasticity, or the property in which the solid materials which does not comes in their regain, or does not regain in the original size, original shape, and both after the removal of deforming force. This example will be when we applying certain heat on any metal, the metal will be melted. Consider a spherical shape metal or spherical shape metal ball, and melt of the metal balls. Then after the removal of these heat energies, after the removal of this heat force, thermal force, then the could not becomes its original size and shape. This is the plasticity, or this property of that metal is plasticity, or the plastic material. Okay, before the rubbing of this all things on the board, just to revise what we are discussing in this type of the concept. Mechanical properties of the solids. Mechanical properties only included in the solids because they have definite size and shape. The mechanic in solids, they have the definite size and shape. What is the deformation? Deformation is one of the process in which we apply certain external force or external deforming force. That's why we call it the deforming force, because it will be changes, it will be taken the part of deformations. The deforming, it is the process in which the object will be changes their size, their shape, or both at a time, size and shape, when we are applying the external deforming force. The deforming force, it is the external applied force, and another one is restoring force. In the plastic material, the restoring force is equal to the deforming force. Then the restoring force, the force tries to, the force which is trying to regain its original shape, size, or both of the object, this is called as the restoring force. Then elasticity, the property of the solids in which there changes, uh, the property of the solid in which the solid object regains its original shape, size, or both. This is called as the, this is called the elasticity. In the elasticity, after the removal of deforming force, this is the elasticity. In the elasticity, the restoring force and deforming force in the equal amount. The magnitude of restoring force is equal to the applied deforming force. Then again, one part is the plasticity. The plasticity is the exactly opposite to elasticity. In the elasticity, the object which are comes in original shape, original size after the removal of deforming force. But in the plastic materials, they does not comes in original position. I will give one of the example, that is metal will be melted, then it can't be comes into its original shape, size after the cool. Then next one part is stress. This is such parameters, stress, strain, and any another things. The stress, it is the applied deforming force per unit area. The stress, it is the applied deforming force per unit area. Just like the heading, that is the stress. Stress, it is the deforming force. It is the deforming. It is the deforming force or applied deforming force. Deforming force per unit area is called as the stress. Stress, it is the applied deforming force per unit area. Then the stress is responsible for the deformation. The stress is responsible. The stress is responsible for the deformation. For deformation. The stress is responsible for the deformation. The equations or the formula for the stress is equal to the applied deforming force per unit area. Area is the scalar quantities. It does not have any arrow on the head, but force is vector quantity. Force have the directions. It means the unit of stress is equal to, the unit will be, the unit of force is a Newton, and the unit of area is the meter square. Then the unit of stress is the Newton per meter square. The unit of stress will be Newton per meter square. Then one another part, this will be strain. What is the strain? We know that stress, it will be responsible for the changes, or it is responsible for the deformations, but strain, it is the another one byproduct of the stress. After the applying the stress, strain will be produced. Strain, it is the ratio. It is the ratio of change in dimension. Change in dimension to the original dimension. Change in dimension to the original dimensions. This is the strain. Strain, it is the ratio in which change in dimensions, how much changes to that original dimensions. Consider one of the example. A rubber string is suspended at a point A, and they have the length is L. Caps L is the length. Before applying the certain external deforming force, when we are applying certain external deforming force, they will be changes their length in certain, that is delta L, and the change in length to that original length, the ratio of these two is known as strain. It means the strain equal to delta L upon caps L. Delta L is the change in length when we apply certain external deforming force, and the L is the original length. But what is the unit of strain? What is the unit of strain? Strain does not have any unit, because the change in length is the unit of, will be meter, and the length is meter. Meter gets cancelled. The strain is the unitless physical quantity. Strain has the unitless physical quantity. These questions will be asked MCQs in any types of the competitive examinations, MPSC, UPSC, or any SETNET or state board exam. This is all about these lectures, the mechanical properties of the solids. In these lectures, we are just discussed the deformations, forces, two types of the forces. One is the restoring force, another one is the deforming force. And Again, we discussed the definitions or just the meaning of these two properties, plasticity and elasticity. Plasticity, and we again revise before the rubbing of the boards. And stress and strain, these most important things which is asked in MCQs or the statement definition unit will be asked in any types of the examination. That is stress, it is the deforming force, it is the applied deforming force per unit area. The stress is also be the pressures. Then the stress is responsible for the deformation. Stress is a reason for the deformations. When we apply certain force on the particular area, it will be stress, and there will be changes their shape and size. It means stress is responsible for the deformations. The stress is equal to applied force per unit area. The unit of the stress is the ratio of unit of force and area. The unit of force is Newton and unit of the area is meter square. Then the unit of stress is Newton per meter square. The strain, it is the ratio. Strain, it is the ratio of change in dimensions. Dimension will be changes of their length to the original dimension. Original dimension of the length is caps L. And strain does not have any unit because they will be ratios of same physical quantity. Okay, we are stop here. In the next lectures, we discuss the types of stress, Hooke's law, and then stop here.